Because certain types of drugs, such as cocaine, amphetamine, heroin, PCP, and barbiturates, to name just a few, are very strong reinforcers, many scientists believe that these drugs make people experience a loss of control, which makes them much more likely to repeat the same behaviors over and over. In this case, continually seeking and using the drug in spite of the negative consequences. By focusing on the amount of time and energy a person will spend to get and use drugs, the reinforcement model of addiction helps to explain the progression of drug abuse. With continued use, drug abusers begin to lose interest in many other reinforcers because they no longer produce as much pleasure or reward as compared to the acute effects of drugs. In addition, the drug effectively allows the drug abuser to escape from unpleasant emotions, including those caused by their drug use. As a result, they'll continue to use drugs despite the negative consequences. So what makes drugs such powerful reinforcers? A closer look reveals that all abused drugs are chemicals that very effectively stimulate the reward pathways. Compared to most non-drug natural reinforcers, drugs of abuse are more powerful, more immediate, and more reliable reinforcers, and require very little effort on the part of the user to feel good. Drugs of abuse are more powerful reinforcers because their impact on the reward pathways is much greater than that of most non-drug reinforcers. While many of us enjoy a relaxing round of golf, the pleasure would be unlikely to match the impact on our reward pathways that is generated by cocaine. Also, these drugs provide a more immediate reward than natural reinforcers. For example, experiencing what is known as runner's high, or experiencing an opiate high from heroin or Vicodin, both involve the brain's natural opiate receptor sites and neurons. But a runner's high can take many hours of training and effort to achieve. Drugs, on the other hand, provide their effects in just a matter of seconds. Drugs of abuse are also more reliable reinforcers and are guaranteed to stimulate the reward pathways. Non-drug reinforcers, on the other hand, are more variable. For example, the pleasure we get from watching our favorite sports team may be short-lived depending on the outcome of the game. Finally, these drugs require less effort than non-drug reinforcers. Drug abusers prefer the ease of snorting cocaine or popping a couple pills for stimulation of their reward pathways over spending hours hiking up a mountain trail. Clearly, for a drug abuser, the drug represents an easy, quick fix or a high-speed expressway to feeling better. That is why it is often such a major challenge for recovering substance abusers to substitute healthier reinforcers for the pleasures they get from drugs and drug-related activities. This difficulty may also explain why some abstinent substance abusers begin to abuse other drugs or develop other compulsive behaviors, such as gambling and overeating. While we can thank our reward pathways for all of our pleasurable experiences, unfortunately, they can also backfire on us. Let's take a closer look to see how the pleasurable experiences produced by taking some drugs can lead to the problem of drug abuse. Inside the brain lies a series of interconnected regions and pathways that together are known as the limbic system. The limbic system contains most of the key structures associated with the reward pathways. Inside the limbic system, the reward pathways are linked to areas of the brain that control emotions, decision-making, and memory. The reward pathways link three important brain areas: the ventral tegmentum, the nucleus accumbens, and the prefrontal cortex. What we experience as pleasure begins with stimulation of neurons in the ventral tegmentum. The stimulation then extends to the nucleus accumbens and into the prefrontal cortex. Research shows that stimulating the reward pathways causes the release of large amounts of the neurotransmitter dopamine. It is the release of dopamine, especially in the nucleus accumbens, that creates the feelings of pleasure we experience when we use drugs. We've seen how the reward pathways link several very important areas of the brain. One area in particular, the nucleus accumbens, houses the brain's pleasure center. It is here, through the release of the neurotransmitter dopamine, that we experience all of the pleasurable effects of drugs. But as we're about to see, sometimes drugs can affect the reward pathways even before we take them. So far, we've talked about how certain drugs of abuse affect the reward pathways. Many of them stimulate our reward pathways by directly causing changes in our brain chemistry. However, there are also other, less direct ways in which continued drug use can stimulate the reward pathways. Many of these indirect ways involve environmental cues, such as the people, places, and activities closely associated with the direct stimulation of the reward pathways. When the reward that results from taking a drug is paired over and over again with certain places, we become conditioned to experience that place as pleasurable. Then, when our reward pathways are stimulated by an environmental cue, like entering a similar type of place, we often experience a strong desire to take the drug. This strong desire is what is known as a craving. Similarly, if you tend to do most of your drugs with the same group of people, you may begin to feel drug cravings just from seeing them. This is because you have associated the habit of drug taking with this particular group of people. This learned association is called a conditioned response. So what are conditioned responses and how do they turn into cravings? The answer begins with a trip to Russia. A century ago, a renowned physiologist, Ivan Pavlov, formulated his groundbreaking theory of behavior involving learned associations and conditioned responses. Pavlov is most famous for his experiments involving dogs, where just before he would feed them, he would ring a bell. As the dogs began to associate being fed with hearing a bell, the dogs soon learned to expect food every time they heard the ringing of the bell. Soon, just hearing the bell was enough for the dogs to become excited. They would begin to salivate, just as though they were actually being fed. This behavior is called a conditioned response. Just like Pavlov's dogs hearing a bell, people also learn to make connections between their environment and the positive reinforcers associated with that environment. Drugs are no different. People tend to associate the pleasurable feelings of drug use with the people, places, and activities that are around when that drug use happens. The biological basis for these environmental cues lies in our brain's ability to rapidly learn associations between events, particularly those that create strong feelings of pleasure, and features of our surrounding environment. The environmental features that evoke cravings for drugs are often referred to as triggers. While some triggers to use drugs are external cues from the world that surrounds us, other triggers may be internal, such as painful memories or unpleasant emotions. Whether internal or external, exposure to these triggers can cause neurons within the reward pathways to release small amounts of dopamine as an anticipatory response. Like Pavlov's dogs being triggered by a bell to salivate in anticipation of food, our brains also learn to anticipate drug effects when exposed to cues associated with drugs. Under these circumstances, our brains release small amounts of dopamine in the reward pathways. These anticipatory responses form the biological basis for the cravings that many drug abusers feel for their favorite drug. By understanding how drugs affect the reward pathways, we begin to learn about the complex processes involved in both the development of substance abuse disorders and in recovery from them. Because drugs can be such powerful and reliable positive reinforcers, we've learned that many recovering drug abusers have difficulty enjoying activities that do not involve drug use. This may be why some abstinent drug abusers develop other addictive behaviors. We also know, based on studies with laboratory animals and human studies with alcohol, that there are likely important biological differences in the brain chemistry of drug abusers versus non-drug abusers, particularly within the reward pathways. We've also learned that because environmental cues can stimulate the reward pathways and lead to cravings, recovering substance abusers should attempt to avoid the people, places, and activities that they strongly associate with their drug use. Finally, We've learned that although being family history positive does not guarantee that someone will develop a substance abuse problem, research clearly shows that these persons are at greater risk to develop this type of problem than someone who is family history negative. And because drug abusers are forced to live in a world that surrounds them with many drug cues, triggers, and primers, they remain at risk for drug-related problems for the rest of their lives.